Welcome to this presentation of Book 2, Module 8, covering the implementation of SLAAC and DHCP version 6. We will be examining how hosts can acquire an IPv6 address, and we'll use Packet Tracer to show the three different configuration methods. Let's begin. Let's talk about a global unicast address assignment. As you may remember from Module 12 of Book 1, a GUA is a globally routable IPv6 address. On a router that is acting as a server, a GUA is manually configured on an interface. Hosts can be manually configured with a GUA. However, entering IPv6 addresses into a configuration is tedious and time-consuming. It's not fun at all. In addition, just as in IPv4, the more addresses you're dealing with, the more likely you are to mistype an address or have a duplication on the network. So when dealing with any network larger than just a handful of hosts, it's best to set up hosts to acquire a GUA dynamically. So if automatic IPv6 addressing is selected, the host will use an ICMP version 6 router advertisement or RA message to help it to auto-configure an IPv6 configuration. This is a setting on the host machine that you will see during our packet tracer configuration. There are three methods used for hosts to be assigned an IPv6 GUA. They are SLAAC only, SLAAC with a stateless DHCPv6, which is really the same thing, only it adds the ability to set some additional information on the host dynamically from the DHCPv6 server. And then there's stateful DHCPv6, which works a lot like DHCP version 4. The ICMP version 6 RA message uses three flags to determine which method is used. There is a test question that you will likely see about this, so you need to understand this. If the A flag is set to 1, then that method is set to SLAAC only. If the A flag and the O flag are both set to 1, that signifies SLAAC with stateless DHCP. And lastly, if the M flag is set to 1, then that is a stateful DHCPv6 server. So let's take a look at configuring SLAAC, which is the easiest method to implement. I'm going to set up SLAAC just on this network right here. And what you need to do is, first of all, turn on IPv6 routing. We're going to set up the interface. We're going to set up gigabit 00. We're going to set up an IPv6 address, which is this address right here. And we're also going to set up the link local address. And that is this address right here, the FE80. And we'll enable the interface. Fast forward the time a little bit. And if we select auto config, it it creates an IPv6 GUA with the network prefix from the router. The interface ID is either randomly generated, or in this case, it's using something called EUI64, which creates an interface ID based on the MAC address of the host. And also the IPv6 gateway is set to the link local address. So that is all we have to do with SLAAC. Pretty straightforward. So let's take a look at SLAAC with stateless DHCP. This network is already got SLAAC enabled. So to set up stateless DHCP, find the pool, the DHCP pool. And we'll name it stateless. It'll help if you're actually in configuration mode. We'll set a DNS server. We'll use just the last address from the first hectet of this the network. We'll set up a domain name of cisco.com, and then this is just used for testing the configuration. We're not going to actually be using that. And let's enable the interface. Use 00. It's already up. And it already has the IPv6 address configured because we already had SLAAC configured on this network. So all we need to do type in IPv6 ND, which is network discovery, other config flag, and that basically sets the flags to be 1 for A and 0, for A and O to equal 1, so that it specifies the configuration is SLAAC with stateless DHCPv6. And assign the DHCP pool to the interface. And that should do that. Let's take a look at the hosts. Set to auto config, and look, we're getting the DNS server that we specified in here. If we were in a real world situation, we could actually open up a command prompt and do an ipconfig all. It would show the domain name that we set up, which is cisco.com, but because it's packet tracer, that won't work. But it is assigning itself an IP address, its gateway, and the DNS server. And that's how SLAAC with DHCP, stateless DHCPv6 works. And speaking of things that don't work exactly in packet tracer, the stateful version of DHCPv6 method is not something that works perfectly in packet tracer as well. We'll get to that though. So DHCPv6 stateful version operates similar to DHCP request, DHCP acknowledgement, etc. that's used in DHCP version 4. And just like in DHCPv4, you can have a dedicated server providing DHCPv6 services, or you can use a Cisco router to do the same thing, which is what we're going to show today. Take a look at the last network here. So we're going to set this server up to be a stateful DHCPv6 server. We're going to set up this interface here to be a client. So it's actually going to be assigned an IP address from this router. All the other hosts will be assigned an IP from this router as well. And again, first thing you need to do is enable IPv6 routing. And we're going to assign a DHCP pool. We'll call it stateful. Assign the prefix. And it's the first 4 hectets of that address right there. We'll assign the DNS server as well. And we'll assign the last hectet of that, the last address in the first hectet. Now we need to make some changes to the interface. And that is gigabit 00. We're assigning it the address according to the information within Packet Tracer. Assign the link local address. IPv6 network discovery. Managed config flag. That sets the M flag to 1. Now there's another command that you need to do to make this completely work. And unfortunately, it's not something that's available in Packet Tracer, but this is the command. And it's going to fail. But this command basically turns the A and the O flags off. So right now, this command here set the M flag to 1. So it shows stateful, but it's still getting conflicting information saying that the A and O flags are set to 1 as well. In the real world, this shouldn't be a problem. Continuing on. Assign the DHCP to the interface and turn the interface on. Let's go forward in time. Now when we go to look at the configuration for this, we're going to set, instead of using auto config, which we'd use for SLAAC, we're going to use DHCP. And notice it's assigning it the default gateway. It's assigning the DNS server that we set. Remember the last address in the last hectare for the DNS server. It's not assigning itself the GUA, the IPv6 address, but that is because it's getting conflicting information on the flags. That's a packet tracer issue. But it is working otherwise. Let me show you how to set up this interface now. We're going to have this interface be assigned the IP address from router 3. And we have to enable IPv6 routing. This is gigabit 000. IPv6 enable, IPv6 address, DHCP. And we'll shut down. We'll fast forward in time. Now look here. This interface has been assigned an IP, a GUA, by the stateful DHCPv6 server. So it works. So this indicates that the configuration we did on this router for IPv6 is working. And the only reason the hosts are not it's not working on the host is that one problem with the not being able to clear the A flag with that command. So that's how DHCPv6 works. Thank you and have a great day.